Hello. In this video, I will talk to you about the flight parameters of unmanned aerial vehicles. First of all, what do we mean by the flight parameters of unmanned aerial vehicles? I want to briefly explain this to you. First of all, what are the factors that will affect us during the flight? Lastly, what are the capabilities of the unmanned aerial vehicle? What do we base these on? And what is their importance? We will talk about these in this video. Now, in order to evaluate the flight of our drone system, we can determine its stabilization or its condition from an engineering and technical perspective. We need to determine the mission of the drone system. For example, in order to determine whether a drone is slow or fast, you need to identify what purpose that drone was designed for. You need to know, let's say you are using an agricultural drone. You can't make a comparison or assessment based on the speed of this drone. If you are working with a standard drone or an FPV drone, so FPV drone is fast. You can't say this drone is slower, while the FPV drone is a much better drone. Drones are categorized based on their missions, so an evaluation according to their specific tasks is relevant here. Based on this, you could also say, for example, the agricultural drone has a higher lifting capacity. The FPV drone does not have a very high lifting capacity. Then it can be said that drones are much better in agriculture. In such cases, as I mentioned, we need to determine drone systems based on their missions. Apart from these missions of the drones, let's take a look at the features that we can refer to as catalog values or catalog specifications for all of them. The first of these is flight time. Each drone has flight times that have been tested by the manufacturer under controlled environments, in airless conditions, at maximum and minimum conditions. These flight times are important for a reason. Let's say you want to integrate it into a project, and within the scope of the project, a 40-45 minute footage is captured. You need a drone that is capable of carrying. In this case, you definitely need your drone system to have a flight time of at least 50 to 55 minutes. Why? Because the drone will take off, start its mission, complete its mission, and your mission duration is between 40 to 45 minutes. You need to account for the drone's takeoff, landing, and returning to its place, so you will need a flight time of 50 to 55 minutes. Or your main goal is to transport a box. You want to make a drone that can carry a box weighing 1.5 to 2 kilograms or even heavier from point A to point B. You need a project like this, so the drone system you will be looking at will need to have certain lifting capacities that are at least equal to its own weight. Now, flight time is one of the first values we mentioned. Our second value is actually the lifting capacity that I mentioned earlier. We call this payload. So the payload capacity, in drones, you will see two values related to this payload, and more specifically, the lifting capacity. The first is the takeoff weight. The takeoff weight we mentioned is actually the weight of our drone itself. It's the weight of the additional load, the payload. Now, why do we call this the takeoff weight? Because this is exactly the value we need to calculate for the drone to be able to reach the distance we want from zero. Another value is given to you at this point, which is the drone's own. It's the weight. So you could say this. So the drone's own weight is 20 kilos, or more precisely, the takeoff weight is 45 kilos. What does this mean? You can lift a load of 25 kilograms. You can load as much cargo as you want, up to 25 kilograms, inside the drone. So, at this point, what is the thing we need to pay attention to? We will take our payload into account. Let's say the weight of our payload is 10 kilograms. So what will the drone's takeoff weight be for us this time? If the weight of the drone is 20 kilograms, it will be 30 kilograms. So the 45 kilograms stated in the catalog is the maximum takeoff weight we can refer to. This is a value that directly affects our flight. No matter how much weight you load onto this drone, there is an inverse relationship here. In our flight time, that's it. It will decrease. So what do we need to pay attention to at this point? Let's say we need a flight time of 30 minutes and a lifting capacity of 30 kilograms. And our drone has a catalog value of a takeoff weight of 45 kilograms along with a flight time of 25 minutes. At a flight time of 25 minutes with full load. So, what did we say here? It said takeoff weight. What do we need? 30 minutes, but we are reducing the drone by about 15 kilograms. What does this mean? A load much lower than the maximum takeoff weight. This means that we will probably easily achieve the 30 minutes. These two values actually exist in all drones. However, these two values vary depending on the missions of the drones. Let's say you want an FPV drone. The takeoff weight won't be provided to you. The weight of the drone is given. Why? Because there isn't too much load on the drone. Let's say you want to add an external camera here. You have a weight of 200 grams. Since there is no value that can be included in this takeoff weight, it is not taken into account. Now, a third value is actually a speed value that is proportional to weight and flight time. Our drone has two different speed values, one for horizontal and one for vertical. Here too, the first one is called climb rate. The speed of the drone while climbing is calculated in meters per second. You can convert this to kilometers per hour yourself, if you want to understand it more easily and comfortably. We also have a speed that is horizontal. Our speed in this horizontal area, for example, let's say you're making a racing drone or a drone for mapping purposes. Here you need to finish mapping that area very quickly. Why? Your flight time. And depending on the size of the area, you need to take these values into account. This time your horizontal flight speed is more important. Why is your climb rate important? Let's say an obstacle will come up in front of you as you move forward. If the drone's climb rate isn't enough to clear obstacles, extend your detection sensor's range. These values help you make an active, accurate choice in selecting a drone for your project integration. Besides these three values, what other values might we consider? You can make a much more active and accurate choice. Now, aside from these three values, what other values might we have? For example, there could be the battery value of the drone. This battery value will already give us the flight time. But why is it important? If you're going to buy or use a spare battery along with the drone's battery value, you need to make a choice accordingly. By paying attention to the capacity value or the battery value here, you can achieve the same flight times. Of course, having the same brand and model of battery is very important here. Now, the second point is different. What can be provided? The motor power can be provided. The motor power will also determine the payload capacity, meaning the useful load it can carry. It will also provide the speed value. Basically, these are the three factors. It will provide the speed value. Basically, these are the three factors. So, what data do we want to obtain from our unmanned aerial vehicle during flight? What are the parameters? So, what are the telemetry data we can collect from the drone itself during flight? The first of these is our speed value. We can instantly retrieve our speed value from the drone. We can see how many meters per second we are moving. The second is location data. We can see the exact coordinates of where our drone is located on the globe. You can directly retrieve data from this flight control board through an external or internal GPS sensor. The third is altitude data. Altitude data is also available on our drones. There are certain sensors, and we have our IMU sensors, our gyroscope sensors. Along with this, you can also detect the orientation of the drone. This will be our fourth item. And at the same time, you can obtain altitude data through these sensors. Now, we have the data that our drone can collect and the data it cannot collect. For example, the wind load affecting the drone. What do we mean by this wind load? Let's say you are flying in a windy environment. This time, you need to know the value of the wind. How do you know the value of this wind? You can know it with an external sensor that you add to the drone. The data you receive from that external sensor. You can receive it as a package. This is a possible situation. So why do we need to know the wind load? Let's say that the catalog values can withstand winds up to 25 kilometers per hour or even 4. You can withstand resistance up to the wind. You can see a data point called durability. This data shows exactly under what conditions your drone will not be able to fly. Now let's say you got a drone that has had a crash. You pulled the last flight data from the black box through the flight control board, and you saw that it was flown in a wind of 27 kilometers per hour. This time it will be considered user error, so that distinction is very, very important. If you are a technical maintenance and repair personnel, now what else can't you see besides the wind? Hot. You can't interpret this nakedness. You can't see the temperature in the outside environment. This is of course valid for extreme situations. If you are in a very cold environment or a very hot environment, if you want to fly the drone, you need to pay attention to the operating conditions of our motors or the working conditions of the battery. How do you measure this? You can measure it with external connections that you will add to the drone. Of course, these two values are actually the ones you need to pay attention to before the flight. For example, you might need to fly in a rainy environment. In this case, you need to know whether your drone is waterproof or not. And these are also the flight parameters, meaning the parameters you can pull from the drone and the parameters you can pull through external sensors. You have experienced any kind of crash, you need to evaluate through the drone and compare it with the given catalog values for the drone. So you can see this. Here is our total takeoff weight along with the payload. 45 kilograms drone, 48 kilograms. Ground was also loaded and the drone then crashed after moving forward. Now this doesn't mean it can't lift 48 kilograms, even though it has a lifting capacity of 45 kilograms. What is called here is maximum. Why is the lifting capacity this? Because the safest lifting capacity is this. Every moment you exceed this actually puts the drone's flight at risk. You would lose stabilization. So, in general, these are the things they can explain about flight parameters and the factors that affect the flight. What else should you pay attention to? The material of our drone is also very important here. The additional equipment you will use is also very important here. So let's say you need a camera for a shoot. If you need a drone system for a project that you really need, then this time you will have to look at the camera specifications. Cameras on the drone are generally sent internally, but in many of them, they can also be configured in a changeable position. You can configure your cameras here according to the situation. These are also the factors that can be included in our flight parameters, I can say drone parameters,